Hey everybody, quick math lesson. A function is a way of taking something and converting it to something else. So it's like a tool for calculating things. There's a couple different ways of doing it. So one way is defining a rule, and that rule depends on the situation. So for example, if I wanted a function to do the area of a rectangle, I could do that. I could say the area of a rectangle is equal to the length times the width. And you've seen this before. The area is equal to the length times the width. And essentially what that says is put in some information, get out an answer, right? And so in this case, there's two variables. There's length and width, and then an answer, which is our area. Let's say we wanted to do it for a square. So this is an area of a rectangle. If we wanted to do an area of a square, because all four sides of a square are the same length, it turns into the side times the side, which is the same thing as the side length squared. So a function rule for area of a square is you just tell me one side and I'll take that number and square it. So the area rule for a triangle, again, hopefully this sounds familiar. The area of a triangle is equal to 1/2 of the base times the height. So each of these are three different functions. They're calculating area. This one's for a rectangle, that one's for a square, and that one's for a triangle. And they have different rules to them, but they work the same way. And essentially what you do is you say, hey, what are my inputs? What things do I know about? I'll throw them into my machine and I'll get out an output, which is this thing. So for example, let's just look at the square one. So if I have my area of a square, if I pass in a 5, this is a way to say passing in a 5, is equal to 5 squared is equal to 25. If my area of a square function is given the value 10 as an input, it spits out the value 10 squared or 100. So it's just a way of saying mapping a value to another. There's a few different ways to write these things. One is kind of like this. So one is like you've seen before, linear equations and equations. So I could say area is equal to the side squared, or if I said y is equal to x squared, you might have seen something like that before. So the input is x, you calculate your stuff, you get a y out. Another way is a mapping table. We talked about those. So if the length of the side is 0, it gets mapped to 0. So this is going to be x squared. If the value of the side is 1, it gets squared to 1. A 2 gets squared to 4. And a 5 gets squared and ends up at 25. So this is a mapping table. So we have a formula. We have a mapping table. Each of these points you could list as a coordinate pair, another way to do it. So you could say when the first one, the input is 0, the output is 0. Input is 1, output is 1. Input is 2, output is, okay, we're still on the screen, 4, and input 5 gives me 25. And let's just go all the way up to 10. And that gives me 100. So I can do a formula. I can do a mapping table. I can list these off as points, as pairs of an input-output pair. Another way to do it is actually writing it as something like this, where you say a function of the variable passed in is, here's the rule, I square the I don't know why there's so many different ways to do this, but these are all ways to write it. All this data can then be shown on a grid as well. So, for example, an area of 0, this would be 0, 0 right here. And let me just switch it over a little bit. There we go. So 0, 0. Side length of 1. So if the side is 1, the area is 1, and this would be the area. If the side is 2, the area is now 1, 2, 3, 4. If it's 3, it goes all the way up to 9. And the air, it does this kind of cool curve thing up into La La Land. Nothing below here, right? Because you can't have a square with a negative side length. I mean, maybe you could theoretically, but it would be tough to draw. Yeah, so there's like 4 or 5 different ways of thinking about a function, but it's just basically a rule on how to do some calculations.